So, an exponent. You have seen exponents in the past. It's something that you should be somewhat familiar with. If we have something like, let's say, 6 squared. This is made up of a couple different parts. There's what we call the base, and there's what we call the exponent. The exponent is kind of that part, that piece right there. It's kind of that subscript. That's telling us what power this 6 is being taken to. So that part of it is the exponent. That's that part right there. It's kind of what we call your power. The second part of this is what we call the base. And in this case, this 6 right here, that's considered to be the base. The base is the number or variable that is being risen to a power, or that your exponent is with. Okay, so we've got a base and we've got an exponent. Now the key to kind of all of this is you've got to be able to understand what the base is. The base is the part that's being risen to a power. If it's not part of it, say we have something like 6x squared, our base in this case is just the x. This is our base. The base is only the part that's being risen to a power or to an exponent. The 6 is not part of the base in this case because it's not being risen to a power. Well, what does it mean when you're taking something to a power or to an exponent? What that simply means is you are taking that base times itself that number of times. So 6 squared, we say, or 6 to the second power, is really going to be 6 times 6, which is just 36. And I'll show you how to do these in your calculator when they're numbers here in just a little bit. If we have something like 6x squared, the 6 isn't being risen to a power, so it's not part of our base. So that 6 is just going to kind of come along when we have 6 times x times x, which, again, is just 6x squared, but you need to understand what part of this is the base of it. So if I have something like negative 7x squared y to the third, we have a couple of different bases on this one because my x value is being squared. So the x is a base with the power of 2, and the y is a base with the power of 3. So if I was going to kind of write this out and expand it, the way we would write this out is we would say that this is negative 7 times x times x times y times y times y. We've got 2 x's, x squared. We've got 3 y's, y cubed. This is kind of what we call the expanded form of that. And you're not going to have to do too much of this today. You're more going to evaluate them. But it's important you understand what it means to be a base and what it means to be an exponent. So let's say that I write something like negative 2 to the 4th power. In this case, what's the base? Not the negative. The only thing that's the base here is the 2, because that's what's being risen to a power. So if I wrote this out, it would be the negative of 2 times 2 times 2 times 2, which would be negative 16. And now we want to be able to evaluate this. The best way to evaluate these is on your calculator. Fastest way to evaluate these is on your calculator. The TI 3012S, or whatever it is, this one, it's the easiest one to use when you're evaluating them, because all you have to do is put in it exactly how you see it. So when you're punching this into this calculator, the first thing you're going to hit is you're going to hit the negative key. Now, the negative key is the one down by the period. It is not the minus symbol. That won't work. So you have to hit that negative key. So hit that negative. Then you're going to hit 2, the number 2. And then you're going to hit this symbol right here, this caret symbol. The caret symbol is the 5th button down, right underneath the pi symbol. You hit that, and now on your screen you should see exactly that. And now you're going to hit 4 because it's to the 4th power. And then hit equal. And it tells you that that's negative 16. Did everybody get this solution? It has a calculator. Now understand that is completely different than that. Now, because of the parentheses, the negative 2 is being risen to the 4th power. So if we were going to expand it out, and again, you're not going to have to do this part of it today. I'm just using it as explanation parts. This is going to be negative 2 times negative 2 times negative 2 times negative 2. You've got 4 of them, a negative times a negative times a negative times a negative. That means it's going to be positive 2 times 2 times 2 times 2 times 2 is 16. And again, on your calculator, you're going to put a parentheses, hit the negative 2, close the parentheses, then hit the caret and the 4. And you are going to get 16. Let's go the negative of 2 to the 6th. Use your calculator to evaluate that. Use your calculator to evaluate negative 2 to the 6th power. What's my base? Just the 2 is the base. And again, don't need to do this part, but this would be the negative of 2 times 2 times 2 times 2 times 2 times 2. So our answer is going to be negative 128, 64, 64. Okay. Yeah, 64. Any questions so far? Last thing that I got to get and understand is, say I got negative 3 to the 74th. And I've got negative 3 to the 75th. So obviously one of these is a really huge number and one of these is a really small number. If you try to put this on your calculator, you're going to get something E probably. Okay, even if it doesn't. One of these is positive and one of these is negative. And we can tell if something is positive or negative if it's written in this form by looking at the exponents. If I square something, it'd be negative times a negative. Negative times a negative is a positive, right? If I cube something, that's negative times a negative times a negative. So something cubed is going to be negative. What about to the 4th? Negative, 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 negative. Positive. So can we think of a conjecture? If it's even, it's going to be positive. If it's odd, it's going to be negative. And this only applies if you've got a negative symbol inside the parentheses. So if you've got a negative symbol inside the parentheses, if your exponent is even, you're going to get a positive result. If your exponent is odd, you're going to get a negative result. Any questions with this? We're good with this part of it. We can evaluate them on your calculator. All right, second part of today then is doing two rules. The first one we're going to talk about is we're going to talk about the product rule for exponents. The product rule of exponents says this, is if you have a base to an exponent, so x to the m. In mathematics, product means to multiply. If you have two bases that are the same, but they have different exponents, so x to the m times x to the n, the result of that is having the same base and you add the exponents. So x to the m times x to the n is equal to x to the m plus n. So for example, if we have x squared times x to the fourth, in both cases the base is x. So the product rule says the base is going to remain the same, and you are going to take the two exponents and add them together. So x squared times x to the fourth is equal to x to the 2 plus 4, which is equal to x to the 6th. And that's your solution to that one. If you have more variables involved, say we have x to the 10th, y to the 3rd, times x to the 6th, y to the 4th. You are taking the common ones and adding them together. So for our x values, we've got 10 in the first term and 6 in the second term. So that's going to give us 10 plus 6. For the y values, we've got 3 in the first term and 4 in the second term. 10 plus 6 is 16. 3 plus 4 is 7. That's your simplified form for x to the 10th, y to the 3rd, times x to the 6th, y to the 4th. You just kind of piece them together as you go along. Well, what happens if we introduce numbers out in front? So now we go 10 x to the 3rd, y, times 8 x to the 4th, y squared. Treat the numbers like you would treat numbers, but you're multiplying. We're multiplying 10 times 8. Okay, so our first term here is going to be 10 times 8, which is our numbers multiplied together. For our x values, our first term has 3, our second term has 4. For the y values, the first term, if you look at that first term, it doesn't really have an exponent. There's understood to be a 1 there. So our y term is going to be 1 plus 2. There's 1 in the first term, 2 in the second term. Yeah? I'm sorry? I didn't hear what you said. You good? What's 10 times 8? 80. How many x's do we have? 7. Y to the 2 plus 1 is 3. That's okay. It's all right. 3 plus 4 sometimes equals 5 in somebody's world. Not ours, but somebody's. It's go with the next one. Yeah.
I thought because there was nothing there, they were going to add those two, and then roughing that, adding two.
You still add it to the y value, and there's still understood to be a 1 there. Yes, put a 1 there. Yeah. Or just understand that it's there. Okay, so let's look at negative 6. X to the 10th, y to the 4th, z, times 3, x, y to the 4th, z squared. See if you can simplify that. Six times 3?
Negative 18.
Now, as far as what do you have to show? I'm assuming you can add 10 plus 1, right? How many x's do you have? There's 11 of them. You have 10 in the first term and 1 in the second term. How many y's do we have? 8. 4 in the first term, 4 in the second term. How many z's do we have? 3. 1 in the first term, 2 in the second term. That's your solution. This is called the product rule. Okay. Any questions with the product rule? Yeah. Multiply 6 and 3. Yeah. Yep. And just always treat numbers like you normally would treat numbers if you're multiplying them together. Figure out each of the exponents so it has 10 x's on the first one. It has 10 exponents in the first one and 1 in the second one. 10 plus 1 is 11. Okay. The next rule then that we have is what we call the negative exponent rule. Negative exponents essentially aren't allowed. Just like you can't divide by decimals, having a negative exponent, something like x to the negative first, we don't like negative exponents. So what the negative exponent rule says is that if you have a negative exponent, the way we can take care of that is we can take care of that by writing it as 1 over x to whatever power that is. So if it's in that numerator, the number on top, you move it to the denominator. We'll talk later about if it's in the denominator, what we do to it. But today, everything's just going to be inside of a numerator. So if we have then x to the negative third, we don't like that negative exponent. So the way we rewrite this is 1 over x to the third. So it just changes where it's at from the numerator to the denominator, and it becomes positive. Just remember, we can always put a 1 underneath there if we need to. Now, if you have multiple ones, let's say we have x to the fourth, y to the negative second. And you're asked to rewrite this without negative exponents. Our base of x has an exponent of 4. That's not negative. So we don't have to do anything with this. But our y value is to the negative second. So when we simplify this, this simplified is going to become x to the fourth over y to the second. We don't have to do anything with this base of x because it's positive. We do have to deal with that because it's negative. So it's important that you're able to identify that base. So if I have something like 4x to the negative third, y to the 10th, and I want you to rewrite that without negative exponents. There's only one base with a negative exponent. So that's the only thing that needs to be moved to the denominator. The 4 doesn't have a negative exponent. So the 4 is going to stay in the numerator. The x to the negative third is negative. We can't have that. So we move that to the denominator. Y to the 10th, we don't have to touch that because it's already positive. So it just stays in the numerator. So you only move from the numerator to the denominator those bases that are negative. Don't touch the ones that are positive. Just leave them where they are. So I'm going to put it together. So the last step today is then taking all of this and putting it together. So let's say we have 3x squared y to the negative 7th times negative 2x to the 4th y to the 3rd. So we're going to take this and put it all together using the rules that we've talked about. So step 1, multiply your numbers together. 3 times negative 2. 3 times negative 2 is negative 6. How many x's do we have total? 2 in the first one. How many in the second one? 4. 2 plus 4 is 6. So we have 6 x's. It's 2 plus 4. The y values. How many do we have in the first one? Negative 7. How many do we have in the second one? So what's negative 7 plus 3? So negative 7 plus 3 is negative 4. We can't have that because we've got a negative exponent. Is the negative 6, is that a negative exponent? No, it's not. There's an exponent that goes up here. So we just leave the negative 6 alone. What about the x to the 6th? Do we do anything with it? No. Nope. What about the y to the negative 4th? Put it on the denominator. There's your solution. Okay, go ahead and give this one a try. Let's go 6x squared y. Let's try that again. Let's go 6x squared y times 2x to the negative 4th y times negative 3 x to the 4th y to the negative 7th. Okay, see if you can simplify that one. Six times 2 times negative 3? Negative 36. X's, we've got 2, negative 4, and 4. So 2 plus negative 4 plus 4 is 2. We've got 1 plus 1 minus 7. Negative 5. Are we done? Nope. What's in the numerator? What's on the top? Negative 36. X squared. On the bottom? Y over 5. And there's your solution. Do we need to do one more?
No. No.
Let's do one more. And we'll call it good. Let's go negative 6, x to the negative third, y to the negative second, times negative 3, x to the negative 2, y. Negative 6 times negative 3? 18, x to the negative fifth, y to the negative 1. So that's 18 over x to the fifth y. Again, it's negative 3 plus negative 2. And the y value is negative 2 plus 1. So there's the product rule, the negative rule, and kind of the basics of exponents. Remember, as you're going through this today, keep in mind what's being risen to your power. The only piece that's being risen to your power is the base. So in this last example, negative 5 power has a base of x. The 18 has nothing to do with it. Your assignment for today is in 2 parts. There's 2 worksheets within your assignment. The first one, use your calculators for. Evaluate means to solve. Use your calculators for the first worksheet. The second worksheet is going to look a lot like the examples that we just did. You have until 12:13, which is almost 20 minutes. It should be enough time if you work on it to get it all done.